Oh, yes. So it's 1 over x plus 1 over x plus 4 equals 1 over 5. Is that it? Okay. One over x plus 4, right? Equals 1 over 5. Just making sure that I copied it correctly. Is that correct? Good. So what type of equation is this? Obviously, it's an equation. But what type is it? Yes. It has a ratio. It must be rational. It has x in the denominator. It must be rational. Very good. It's a rational equation. What do I have to do? Assuming you are using the method that I presented, you don't have to. So I will subtract 1/5. I will move 1/5 to the other side, set it equal to 0. And then, yes, I will find the least common denominator, not before I will write two restrictions.
Can't be 0. It can't be -4.
Awesome. Do we all agree with that? Very good. Good. So now I have to find the least common denominator. And that is the least common denominator. I see 3 factors. I see x, x plus 4, and 5. What is the least common denominator? We do not multiply the factors in the denominator ever for any reason. We leave it as the denominator will always be in the factored form. The least common denominator. I'm not talking about the numerator.
X plus 4, x minus 5.
There is no x minus 5 in the denominator, so I can't make up a denominator that is not there or a factor that is not there.
X times x plus 4.
Awesome. All different factors must be part of the least common denominator because otherwise I will not be able to get the adjustments at the top. Awesome. X was multiplied by
5.
and
5.
5 times x plus 4. I'm going to write it up here. 5 times x plus 4 as 5x plus 20 to make my life easier. X plus 4 was multiplied by? I have to multiply the top by 5x. And finally, 5 was multiplied by? So if 5 is here, and I multiply 5 by something to get this, it cannot be 1 or it cannot be 5. It must be exactly
X times x plus 4.
x times x plus 4. Exactly what it does not have, which is x squared plus 4x. Is this clear? It's okay if you say no, and I'll give another example for us to see what is happening here. Are we okay with this?
Can you give another example?
Right. So, for example, when I add 1/2 to 1/3 to 1/5, the least common denominator has to have all these factors. So this must be 60. 2 times 3, I'm sorry, 6 times 5 is 30, sorry. So 2, 3, and 5 have nothing in common. So the least common denominator has to be a product of all 3. Do we agree with that? That's numerical, right? Good. So then 2 was multiplied by what to get this?
15.
That's why I have 15 here. X was multiplied by what? By 5x plus 20. X plus 4 was multiplied by what? By 5x.
Hold up. Can you go back to the first one?
And 5 was multiplied by what? By x squared plus 4x. So, coming back here, don't forget your thought. Hold on 1 second. So, 3 was multiplied by?
10.
5 was multiplied by? Good. Exactly the same procedure. Everything is the same. It looks differently. It looks more difficult because it has x in it. but the procedure is identical. So then I will have 15 plus 10 plus 6. 15 plus 10 plus 6. Is this better? Do we understand what's happening here? So we are only mimicking this. So one more time, x was multiplied by this and this. That's why I have 5x plus 20 up here. X plus 4 was multiplied by 5x. That's why I have 5x here. And 5 was multiplied by x squared plus 4x. That's why I have x squared plus 4x up there. Better? Any questions?
Where did the 20 come from?
5 times 4.
5 times x, 5 times 4.
Okay.
Is this better? Okay, good. So now can anyone dictate the numerator of this fraction? Yes?
Times x, 5x plus 20.
Perfect. Plus?
Let's see, 5x
Plus 5x.
x squared plus
But it's minus in front.
minus.
And then? Are we together? Yes? I don't want to lose anyone. Are we okay with this? Okay. Now, the next step would be to combine like terms at the top and arrange everything in descending order, right? So I have the negative x squared, and then I have these three terms. 10 minus 4 is 6. So plus 6x, and then plus 20, divided by 5x, x plus 4 equals 0 over 1. Is this okay? Please let me know if you have any questions, anytime.
It says x2 plus what? I can't see at the top.
I copied negative x squared here. I have 5 plus 5 minus 4, which is 6x. And then I copied 20. Was that the question, Antoine?
No, over 1
Sorry.
over 5, this is x2 plus.
So x times x is x squared, and x times 4 is 4x, because I only have 5, and I need to multiply these two and put it up there. Is that okay, everyone? Okay, perfect. So then the final step, almost final step, is what? Cross multiply. So negative x squared plus 6x plus 20 multiplied by 1 equals? Very good. Now this is what type of equation? Awesome. I refuse to solve a quadratic equation with a negative leading coefficient. That's me. Okay? So I refuse to have a negative leading coefficient. So I will multiply both sides by negative 1. And remember we discussed 4 methods. I can eliminate immediately few of them. For example, complete the square. Absolutely not. Taking square roots is not ready for taking square roots. Factoring is not factorable, right? Because 20 is 1 times 20 or 4 times 5 or 2 times 10. There's nothing else. I can get a negative 6. So what is the last one? Last chance. Very good. Excellent. So then x equals. See why that's one of the reasons why I eliminate the negative leading coefficient. Because I don't want to have in the denominator a 2 times a, which is a negative number. You don't want that. Because it's very easy to forget about that negative. Or omit it, or who knows what I'm going to come up with. So negative b, what do I write? Negative b, 6, plus or minus the square root of. Very good, awesome. Minus 4ac, but I have a minus here, so I'm going to change this immediately into positive. Minus 4ac divided by 2a. Is this okay?
Why did you change the minus 2 plus?
I refuse to solve a quadratic equation with a negative leading coefficient.
No, the 36 plus 80.
Oh, because I have minus 4 times positive times negative.
Oh.
If I put too many negatives in parentheses and it
Yeah,
looks, but you can't. It's not a mistake. Good, so then x equals 6 plus or minus. I have to add these two. 116 divided by 2. I have to look at 116 and try to simplify it. So prime numbers of 116. So I know that it's a even number, so it must be divisible by. Awesome. So then when I divide 116 by 2, I get 58. It's still an even number, so it must be divisible by 2. And then 58 divided by 2 is 29, indeed. And I can continue. 29 is a prime number. But I have to come back and write 6 plus or minus the square root of 4 to the square root of 29 divided by 2. Now here's a question for you. Can I simplify this 2 with this 2?
Yeah.
I want to cross out this 2 with this 2.
You can.
So yes or no? Never. Why? Because we only simplify only factors we simplify. 2 is not a factor here. Be very careful. 2 is part of a term. What you can do, you can factor out 2, that I will agree, and simplify, or separate the fraction into 2 fractions, and then you can simplify. So 2 times what? Very good. Plus or minus? Indeed. And now I can simplify. So the solution is 3 plus or minus the square root of 29. My first thought, my first concern is here. Are these 0 or negative 4? No.
Would you accept 6 plus or minus 2 square root?
This comes from my math lab. So I don't know, let's read the question, what it was asking, if you remember. What does it say?
Solve the equation by method
Of your choice. The solution set. Okay, so it doesn't tell us how to write the solution, approximation or not, then it has to be exact. So this.
So 3 plus or minus square root of 29.
Right. Right. They may ask you to write them separately. There is no need to do that, but you may not have the plus and minus sign in there in the on the keyboard. I don't remember exactly right now. I can look, but so that's why they may ask you to separate them. And it doesn't matter the order you present them in. Very good question. Thank you. Is this clear? Every step of this problem, is it clear? So you must practice it and be able to reproduce this on your own with other problems as well. And then you can say in your notebook, second half of the notebook, I know how to solve rational equations. I do this, I do this, I do this, I do this. Yes, please. Next question.
So it doesn't have to do with the quadratic formula, but I had a problem in my math lab where I saw the problem and it wouldn't even let me type in the right answer. I double checked it. That it was the
I
right
have to see the problem. Do you have it?
It was a fraction all in parentheses, so it was. This was a problem, and the exponent of b was 45. That's what my math lab said it was.
I know I have to copy it. So if we copy it correctly, then you know. Negative 32, a to the 5th, b to the 8th. Please make sure that I copied it correctly. I do have your classwork from last time. I graded it. I posted, I forgot to show you, I posted your the solutions. You can still ask questions if you have any, of course.
You copied it, correct?
Okay, so let's work on this and then I will return your classwork. Okay, very good. So first of all, I simplify as much as I can. Remember, simplify factor, it's always in the back of our minds. So I will simplify 8 and 32 by 8. So then I get -4. I will simplify these by copying the base and subtracting the exponents. 5 minus 10 is -5. And then I will copy B and subtract the exponents. 8 minus -7 is +15. Is this step understood? Yes? Copy the base, subtract the exponents in both cases. And here, yes?
8 minus 1. 8 minus 7.
So 5 minus 10 is -5. 8 minus -7 is 15.
Oh.
Is that okay? So always ask a question. It's okay if I go back and check it and there is no mistake. It's fine. I'd rather go back and check. So now we raise each and every factor to the third power. -4 raised to the third power is -64. A to -5 to the third power is -15. B to the 15th, 15 times 3 is 45. These will stay at the top, but this has to go to the denominator because it's a negative exponent. So 64, b to the 45th power divided by a to the 15th. Any questions on this?
Why did you leave the 64 at the top if it's negative?
The power must be negative
Okay.
to bring it down. If it has positive, the power here is +1. I'm not allowed to move it anywhere.
Okay.
As long as the power is positive, I can't touch it. I can move a negative number to the denominator because it's negative, right? Only the power will bring it to the denominator.
Okay.
Is this okay now?
Yes.
Every step? Perfect. Yes. Other questions? Yes.
2x equals
2x to the 4th equals 432x. Two x to the 4th equals 432x, correct? Perfect. Very good. What is the degree of this polynomial? How many solutions do we have to have? Absolutely. The degree dictates 4 power degree 4 solutions. Good. First, if you remember, factor simplify. This is an equation. I'm not allowed to divide by the variable, but I'm always allowed to simplify it. And I'll simplify it by 2. So then I have x to the 4th, and I move 432x to the other side. 432, I get 216x equals, what is left? Awesome. Very good. Now, it's in descending order, greatest common factor. Yes. What is the greatest common factor here? Very good. What is left in parentheses? Very good. Negative coefficient? No. Is this a binomial? Yes, it is. So it's not a trinomial, not a polynomial. It's not this, because this is not the difference of squares. It's not this, because this is not the sum of squares. And it is this, indeed, because it's the difference of cubes. So therefore, I continue trying to find what number cubed is 216.
6.
6 indeed. So then I continue factoring this as x I have not refreshed your memory on this formula. So allow me to refresh your memory on this formula, and then we'll come back to finish up the problem. So whenever we are asked to factor the difference of cubes, obviously this is the difference of cubes, or we are asked to factor the sum of cubes, these two factor into a binomial times a trinomial. Both of them. Let's establish the sequence of signs first. If we're asked to factor the difference of cubes, the binomial has the difference, same sign, and the middle has plus. What do you think, just a wild guess, if we are factoring the sum of cubes, what should the binomial have? And what should the trinomial have in the middle? Right. So the last one I don't even talk about. The last term is always positive. Don't worry about it at all. So now here's a question for you. What do I cube to get a cubed? I know it sounds silly. A squared cubed will be a to the sixth. So what do I cube to get a cubed? Right. What do I cube to get b cubed? Very good. The same thing here. Now you remember our contract. I don't have the formulas here, but this formula has a 2 in the middle, right? 2ab. And this one has minus 2ab, right? This one does not have the 2. So this portion is the same with what we discussed on the first day without the 2. So I square the first, just multiply the 2. Oops, I just said no 2 and I was starting writing a 2. And b squared. Square the first, multiply the 2, and just square the second. So now coming back to this problem, since I have the difference of cubes, what will the binomial have? What sign will the binomial have? Negative. And what sign will the trinomial have right here in the middle? Perfect. So now, what do I cube to get x cubed? Awesome. What do I cube to get 216? Awesome. And now carefully make up the trinomial. Just following the pattern.
X squared plus 6x.
Awesome. Plus?
36.
That's it. That's it. Good. Perfect. So if you do not remember these two, I would put them together with the strategy of factoring right here with these two. Because this one was in the agreement, this one is not factorable. Using integers, correct, to be exact. And these two, we discussed them today. Okay, perfect. So now I have this equation, and for now you can give me 3 options. You will give me the first option to be equals, awesome. You will give me the second option,
-6.
careful, -6 minus 6 is not 0. Yes, because you have to move -6 to the other side. Very good. And what will be the third option? Well, all this to be 0. However, when we try to use the quadratic formula on the second one, it will give us imaginary numbers. Let's try. And we can stop. The solutions are these two real numbers. From here, we'll have 2 imaginary numbers. But we haven't reviewed imaginary numbers, so at this point in time, the problem should ask us only for real numbers, correct? So what does the question say? Solve the final way of having then use a zero product principle. Find the solution set, select this choice below. Use the solution set, there is no solution. I am pretty sure that they don't want imaginary solutions, but let's write them. I don't think they do?
It's not they do.
Imaginary? Okay, then we have to finish it up. Good, perfect. Good. So, it's not factorable. I'm not going to complete the square. I cannot take the square root. The only option is awesome. So, negative b plus or minus the square root of.
36.
Very good. Minus 4 times a times c. I'm going to write it like this. You'll see in a moment why. Divided by 2a. So we continue, right? So this is negative 6 plus or minus. I don't want to multiply. I don't want to subtract. I want to factor. Can anyone tell us what will I factor under the square root from these two terms so I can make my life easier instead of multiplying and then not knowing what to do with that big number?
180, negative 180.
What will I factor out from these two terms? This is one term and this is the other. 36. What do I leave in parentheses and how many terms do I have to have in parentheses? 2 terms because I started with 2 terms. What is left from the first term? Exactly. 36 times 1 is 36, of course. I'm here now with minus. Minus what?
36.
36 times what is 4 times 36? 4. Let's do this again because I'm not sure everyone could follow here. 36 times 1 is 36, correct? 36 times negative 4 is negative 4 times 36. We agree? Okay. So now this is so much easier than having to deal with a big number. So from here I have negative 6 plus or minus. How much is the square root of 36? How much is the square root of negative 3? Are you with me with this? We did not review complex numbers. Do you remember this or do you want me to review complex numbers? Okay. The reason why we need complex, I'll come back, it's not done. I'll come back in a second. So allow me to talk about complex numbers for a minute. So when we want to solve the equation this is always a positive number because it's squared, right? Plus another positive number. When I add 2 positive numbers, could I ever get 0? No. So this equation has solutions, but they are not real numbers. So I will move one to the other side. And this is already a contradiction in real numbers because this is a positive number and this is negative. Can I say ever that there exists a positive number that equals a negative number? No. So I will take the square root because this is typical for taking square roots. But I have a problem with the square root of negative 1. This is not real. Doesn't exist in real numbers. So this is what we call the imaginary unit. Imaginary unit. So when I take square roots, what do I always have to remember to write? Thank you. So these are the solutions for that. So now when I come back here with this 36 or the square root of negative 3, the square root of negative 3 will be broken down into 2 pieces. The square root of negative 1 times the square root of 3. But what is this? Indeed. So that's how I get the I, the square root of 3. And now I have to come back because this is not simplified yet. So, can I simplify 2 with 6? The answer is no. Why? Because 6 is part of a term. It's not a factor. So now let's do the other way. Let's separate the fraction instead of factoring. So you can see the other way. So this is x equals negative 6 over 2 plus or minus 6I, the square root of 3 over 2. Now I can simplify. Because 6 divided by 2 is 3 with minus in front. And now I can simplify and say this plus or minus 3I, the square root of 3. So I can simplify the fraction by itself, but I cannot simplify a factor from the denominator with a portion of a term from the top. I can't do that. So how many solutions did we expect? How many did we get? 0, 6, and what else we got? Negative plus or exactly 4 solutions. 2 happen to be real and 2 happen to be imaginary. Yes, Antoine, go ahead.
How did you get 6? X,
6
up.
here.
No, down. Negative 6 plus or minus 6. Where do the 6?
The square root of 36 is 6, and the square root of negative 3 is I, the square root of 3. So the square root of 36 is 6. The square root of negative 3 is I, the square root of 3. This is a product. So I can take the square root from 36 and take the square root from negative 3. So this is square root of negative 3 is the square root of negative 1 times the square root of 3, which is I, the square root of 3. Is that okay? Good. Is there anything else? Do you have other questions for me?
You do that sheet back up.
Anything else? Other questions for me?
Yes.
Yes.
There was a problem at 1137 that was showing their drafting to the Y1, Y2. I printed out the stuff I went through.
So which one am I looking at?
So I just screenshotted this. I'll try to look through it.
That just is the original problem.
Right here.
So this is the original problem. It says the table of values. Any questions for me? Any questions? Go ahead.
No, I was asking.
Okay. The table of values was generated by graphing ability, and use the table to determine which point the graph of y2 crosses the x-axis.
So
Crosses the y-axis, I'm sorry.
So, yeah.
So when I determine the y-intercept, I have to make what? Equal to what? Right. So all I have to do is just look here and I see x equals 0. So for y2 is negative 3.
It told me it was wrong.
But it says nice work.
That was
0, negative 3. And it says nice work.
oh, sorry. So I did. See here, I did 0, negative 3, and it told me it was not correct. So I did help me figure this one out. Steps.
Well, this
And it came up with the same
It
answer.
could be a glitch somewhere.
Oh, okay. So
Always email me and I'll give you the point. I look at what you did, I look at the solution, and I can.
it gave me another problem that was similar that I guesstimated my way through.
Yeah, it's possible. It's just a software. So
Okay.
don't worry ever. Shoot me an email. I'll take care of it and give you the point.
Okay.
Anything else? Anything else? Yes. This is a inequality. Okay, did you distribute? Did you move terms around? Is there something? I don't remember all your names. I remember Tim, of course. I remember Susan. Trisha? Here. Okay. Now I remember Trisha. I remember Chip. Oh, sorry. for Kathy. Shelby? Okay, now I remember Shelby. Sorry, it takes me normally about 2 weeks to actually. Antoine? Mark?
There.
Yes. Remember David? Thank you. Kelsey? Yes. Elizabeth? Shannon? Jay? Right here. And Bob? Did I return all classwork? What is your, can you pronounce your name? I'm sorry?
Caitlin. Yes.
Did you turn it in?
Like, I was the second person.
It could have been sweet and I was hungry. I don't want to waste the time, I will find it. If not, I have to give you full credit. Did I post a grade for you? Ah.
I checked on the syllabus, but I was here last class. I have the alternates from last class.
I believe you. My mistake. We'll figure it out. Yes, Mark?
Question. It says for January 29th, classwork 0 out of 10. Is there something I was supposed to hand in on the first day of class for classwork?
On the 29th?
Online, on the.
Everyone who was here got 10.
I was 0 out of 10.
Okay, I'll check that.
I'll
Okay, let's not waste time on that at the end of the class. No, it's not.
I'll email you.
Yes. No. I'll correct it at the end of the class today because I may forget. Okay. Any questions? Is there anything else? Inequality. A linear inequality. Is this the last one? Because we're not going to be able to do anything today. Just the absolute value or the inequality. The absolute value. Is the other one clear? Okay. So let's take a look. The absolute value of x minus 1 greater than or equal to 3. There are two types of absolute value inequalities. Quiet, please. Quiet, please. Quiet, please. Thank you. So x minus 1, it was less than or greater than? Greater than or equal to 3. Very good. Perfect. So there are two types of absolute value inequalities. One of them that is like this. I'm looking at simple examples before I come back here. And the other one that is like this. How do I know how to address this, or how do I know what to do in either one of the two situations? The key is to understand what they are asking us to do. So here it is. Here I'm asked to find numbers. Remember that the absolute value is the distance. So I'm asked to find these numbers whose distance from 0 is 3 units or less. So imagine the real line. Where will I find numbers that are exactly 3 units away from 0? Negative 3 or? Yes. So negative 3 and 3 are exactly 3 units away from 0. We agree? Perfect. So now here's my question. Where will I find numbers whose distance from 0 is 3 or less? That's all I wanted you to say. So then this is negative 3 less than or equal to x less than or equal to 3. Awesome. Now let's identify this one. This one says find numbers x whose distance from 0 is 3 units or more. Exactly. That's the answer. Outside. Outside means two different inequalities that will replace this one as outside greater than or equal to 3 or less than or equal to negative 3. The outside. less than or equal to -3 or greater than or equal to 3. Nothing inside. So this is the most difficult of the two situations because the solution has to have the union in between. So I have to start here with -∞, -3. Union what? Exactly. So this is our situation now. So I'm asking myself, first of all, which type is it? So I'm going to cover it and say this. I'm asked to find numbers whose distance from 0 is 3 units or more. I have only two options. Either in between or outside. Which one is it? Outside. So I have two options, and they cannot be presented in a chain. This is nice, but I can't use it. Has to be this. So x minus 1 must be greater than or equal to, yes, or in other words, the union, x minus 1 must be, awesome. That's the outside, less than or equal to -3 or greater than or equal to 3. So therefore, the first inequality will be, I'm adding 1 to both sides, x greater than or equal to 4. And the other one, I'm adding 1 to both sides, less than or equal to -2. I am waiting for you to dictate. Yes. Awesome. -∞. Awesome. Union? Awesome. That's it. Very good. Very good question. Very good question. Anything else for me? Anything else for me?
Will you be assigning homework to turn in class, or just what's on?
What is on my math lab?
That's all.
Yes, because we're doing classwork every time we meet.
Okay.
Yes, please. I'm sorry? Yes, yes, yes. Everything in my math lab is at home. Okay, so other questions for me? Okay, so let's go back quickly and refresh our memory. Okay, finally that I can get rid of. So I posted your solutions. You have two versions of everything. So please look at those solutions. And if you have any questions, you can still ask, of course. So last time we looked through equations, rational equations, quadratic, taking square roots, completing the square quadratic formula. And we did not get the chance to look at 1.7. So you guys are way ahead of me. So that's awesome. So now I can move on. Perfect. So do we still need absolute value inequalities? Or we understand the difference between the two? There are only two types. Very good question, actually. Very good question. Anything else? Anything else for me? Anything else? Okay, so in that case, I'd like to talk about functions, chapter 2. If you have anything for me, please. Were you here last time? No, okay. Functions. Okay, so let's look at 3 different scenarios. Scenario 1, Scenario 2, and Scenario 3. So let's say imagine I have some numbers here, and let's say I have a correspondence. This number corresponds to this number to this number to this. Let's say I have this correspondence now in the second example. And let's say the third example is this. We know what a function represents. A function does what? Exactly. Has an input and has an output. If we create a function and I say x equals 5, you should be able to give me an answer. That would be the output. So for each x value, there is only one y value. Is this a function? For each x value, just one y value? So this is a function. For each x value, or to each x value corresponds only one y value. This set is called domain. This set is called range. Of course, this corresponds to x values, and this corresponds to y values. Let's move on to the second one. Is the second one a function? No, because we see that to this x value corresponds to different y values. Is this possible? Yes. Does it exist? Yes. But it's not a function, but it's called a relation. So the answer to those two bubbles is the same. So this is still the domain, and this is still the range, but it's the domain and range of a relation, not of a function. Okay, what about the third possibility? Is the third one a function?
Yes.
Yes, it is a function, indeed. Still domain and range. To each x, it corresponds only one y. So all the first and the third are functions. The second one is not a function. Now, here's the difference between these two. It's a big difference. Now, imagine, can we turn off the volume on that? Do you need help to do that? Do you want me to help you with that, Antoine? Turn off the volume? Okay, so looking at these two, imagine that this time I want to go back. In other words, from here. So from the second set to the first, and from the second to the first. Can I create a function going backwards?
Yeah.
Can I create a function going backwards here? No. So this first function has a key property that not only, by definition, each x corresponds to only one y, but also vice versa. Each y corresponds to only one x. For that reason, this function is called 1 to 1. This one is not 1 to 1. This one will have an inverse. That's what it is, an inverse, but not a function. This one has an inverse that is a function. But that will come in later in chapter 2. Okay, so just keep in mind, this is not for test 1. This concept is not for test 1. Everything else is. So I will come back to that concept later. Okay. I would like to choose a graph of a function and read its domain, range, and potentially a value. So on page 231, I would like to look at problem 81. from this graph, can I conclude that this is a function or not? By the vertical line test, for each x value, there is only one y value. So if I draw this vertical line, it hits the graph in this point, and I will only read one y value. For that reason, this is a function by the vertical line test. Okay, can anyone identify the domain of this function? From the leftmost x value, from the leftmost x value to the rightmost x value of the function, between 0 and 5. However, this is an open point. So at 0 will be a bracket, but at 5 will be a parenthesis, because this is not a full point. This is a full point. Okay, can anyone identify the range for us? From the lowest y value till the largest y value. From -1 with a bracket till with a parenthesis. Okay, and I want to determine f of 3. How do I determine f of 3? What is given in the question? X is given. So when I'm given x equals 3, I know it's a vertical line. X equals 3. So I draw a vertical line at 3. I see it crosses the function at this point, and I will be reading the y value for that point, 1. So which point did you read from? 3, 1. 3, 1. Any questions? Any questions? Okay, we have no, not yet. We still have time. We have until 8:50. No, not yet. Okay, next question. From problem 90, I would like to identify the domain and range. I don't know what they, in my book, for some reason, they gave me a book with answers. So don't disregard those. So let's take a look at this function. What is its domain? So from the leftmost x value, oops, there is no x value here, jump.
Are you doing 90 or 89?
90.
Are you doing 90?
From the leftmost point to the rightmost, from the leftmost point x to the rightmost point x, what will I write?
0.
From -infinity till what? 1 with a parenthesis, union from 1 to infinity. What about the range, please? From the -infinity till 0, union 0 to infinity. So the range does not have 0. The domain does not have 1. So one more time, let me write this down for you. So for problem 90 on page 232, domain does not have 1. -infinity 1, union 1 to infinity. And the range does not have 0. -infinity 0, union 0 to infinity. I'm sorry? Oh, of course. I'm sorry. I forgot. Sorry about that. Any questions? Any questions?
Can I see the graph again?
I'm sorry?
Can I see the graph again?
Yes. Very good.
So like on another problem, like they wouldn't draw that dotted line, right?
Oh, they have to. That is
They
called a
have to?
vertical. They have to. Yes, they have to. If the dotted line is not there, you will not know where the domain is. It has to be. It's called, later in chapter 3, we'll deal with this. This is called a vertical asymptote. Yes, it has to be there. Otherwise, you will not know what x value cannot be plugged in the function. This is the value that cannot be plugged in the function. The function does not exist when x equals 1. Yes. Any questions before we move on? Okay. Now, let's assume I have the following graph. Here's my graph. This particular point, which is the highest point in this interval, I can show you a small interval around that point where all function values are smaller than the function value at that point. Would you agree? This is called a local maximum. The word local, in some books, you'll find it as relative. Relative max or local max. Can anyone tell us what this would be? Very good. Local minimum or a relative minimum. Now follow my marker and hopefully you agree with me that this trend is definitely increasing, an increasing trend for this portion of the function. Would you agree? Now from the local max to the local min, the trend is clearly decreasing. And then beyond the local minimum, the trend is clearly increasing for this function. Agreed? So we could say to someone, well, a patient had an increasing blood pressure, then he or she got a medication for it, and the medication wore off after a certain period of time, but the blood pressure was decreasing, and then it reached the minimum, and then the person needed the medication, and he or she wasn't given right away the medication, and the blood pressure started increasing again, as an example. Okay. So whenever we are asked for these functions, whenever we're asked to find an increasing trend, we're not asked to find it from which to which. No, we're asked to find for what time frame or for what period or for what x values the function follows this trend, and then for which x values the function follows this trend. So if I put some numbers on this graph, like for example, let's say 10 and let's say 18, I would say the function is increasing for x values between negative infinity and 10, union 18 to infinity. Because that's where the increasing trend happens. For any x value between negative infinity and 10, the function is increasing. And also it's increasing for any x value between 18 and infinity. Look at it. But the function is decreasing for the interval between 10 and 18. We're not interested from which value is decreasing to which value is decreasing, but where the trend happens.
Is that why you put the union there?
Because it's this piece and that piece, and there is nothing else I can do. When I put pieces together that are not touching, I have to use the union. Yes, thank you. Very good question. So here is 10 to 18. So the function is decreasing or increasing. Okay, I'd like to look at a problem on page 251. It's a long problem. Let's look at, I wish I could let you choose. Yeah, let's say 52. On page 251. I'm going to copy the graph. It's a long problem because it has a lot of questions. Okay. First question here is, and I may make up some more questions based on what I think we should look at. Is this a function? Why is it a function? By the vertical line test. Question number 1. By the vertical line test, this is a function. 2, domain. I'd like us to find the domain of this function. What is it? From negative infinity, I agree, because of the arrow. It says it continues forever.
6.
Yes, indeed, this was a 6 and comma 6. Bracket or parenthesis? Awesome. If you have questions, I'm sorry? So in the book, if you have the book, it is indeed 6.
So how come you wouldn't put -3 because it has the arrow? The arrow is the cell.
You're asking about the domain?
Yeah.
From the leftmost possible point for x to the rightmost possible point for x. The arrow goes on forever to negative infinity to the y and to the x. If you extend this portion forever, you will get negative infinity for x. Yes. So this is indeed 5 in my graph, but from the book, if you have the book or look at the book, it is 6 indeed. So what about the range? So the range is from the smallest possible y value to the largest possible y value.